Hey there, science fans! Today we're diving into the fascinating world of recurrent neural networks, or RNNs for short. They're like the rock stars of the artificial intelligence world. But first, let's talk about neural networks. Imagine our brains with billions of neurons connected. Neural networks are kind of like that, but in computer form. They learn from data, just like we do. They're made up of interconnected nodes, like tiny brain cells organized in layers. Each connection has a weight, showing how important it is. By adjusting these weights, neural networks can learn to recognize patterns, make predictions, and even understand us. Neural networks are already doing amazing things, like recognizing faces in photos and translating languages. But what if we could make them even smarter? Enter RNNs. RNNs are a special type of neural network that can remember things. That's right, they have a memory. This makes them perfect for dealing with data that happens over time, like language, music, or stock prices. Imagine trying to understand a sentence. You need to remember the previous words to make sense of it, right? RNNs do the same thing. They take in information one step at a time, but they also keep track of what they've seen before. This memory allows RNNs to understand the context of information. It's like having a little notebook where they jot down important details as they go. Pretty cool, huh? So how do RNNs actually remember things? The secret lies in their hidden states. Think of hidden states like the notes in their little notebooks. Each time an RNN processes a piece of information, it updates its hidden state. This hidden state is like a summary of everything the RNN has seen so far. It captures the important information and carries it forward to the next step. It's like passing a secret message along a chain. These hidden states are what make RNNs so powerful. They allow the network to learn long-term dependencies in data, making them perfect for tasks like language translation and speech recognition. Now let's talk about how RNNs process information over time. They do this using loops and time steps. Imagine a conveyor belt carrying pieces of information. Each piece represents a time step. The RNN processes one time step at a time, feeding the information into its hidden state. This hidden state then loops back around and becomes an input for the next time step. It's like a continuous feedback loop. This loop allows the RNN to learn from the past and make predictions about the future. It's like having a crystal ball that can see patterns in time. Section 5. Talking to computers, RNNs in speech recognition. One of the coolest applications of RNNs is in speech recognition. Remember those voice assistants we all use? Yeah, RNNs are the brains behind them. When you speak to your phone, the microphone picks up your voice and converts it into a digital signal. This signal is then fed into an RNN, which analyzes the patterns in your speech. The RNN uses its memory to understand the context of your words and figure out what you're saying. It's like having a tiny translator in your pocket. Section 6. Writing like Shakespeare, RNNs in text generation. RNNs aren't just good at understanding language, they can also generate it. That's right, they can write poems, compose music, and even create realistic dialogue for chatbots. Remember those hidden states we talked about? Well, by feeding an RNN a starting word or phrase, we can prime its hidden state. Then, we can let the RNN generate text one word at a time based on its learned patterns. It's like having a ghostwriter in your computer. Of course, the results aren't always perfect, but they can be surprisingly creative and entertaining. Section 7. RNNs aren't perfect, limitations and challenges. As amazing as RNNs are, they're not without their limitations. One challenge is that they can be difficult to train. Remember those long-term dependencies they're so good at learning? Well, sometimes those dependencies can be so long that the RNN gets confused. Another challenge is that RNNs can be computationally expensive. They require a lot of processing power, especially for complex tasks. This can make them slow and resource-intensive. But hey, even scientists face challenges. Researchers are constantly working on new and improved RNN architectures to overcome these limitations. Section 8. The future of RNNs, smarter and more powerful. The future of RNNs is bright. Researchers are developing new types of RNNs, like long short-term memory, LSTM networks, and gated recurrent units, GRUs, which are even better at handling long sequences of data. These advanced RNNs are being used to develop even more sophisticated applications, like real-time language translation, personalized medicine, and even self-driving cars. Imagine a world where computers can understand us perfectly. translate languages instantly, and even help us make better decisions. That's the power of RNNs. Section 9. RNNs. The brains behind the future. So there you have it, science fans. Recurrent neural networks are changing the world as we know it. They're helping us communicate better, understand our world more deeply, and even create new forms of art and entertainment. As RNNs continue to evolve, who knows what amazing things they'll be able to do. One thing's for sure, the future of AI is bright, and RNNs are leading the way. Keep exploring, keep asking questions, and never stop learning.